Hello there. This is AJ Singh from Pumari Tech. I'll be your instructor to teach this exciting course, Linux kernel driver programming with embedded devices. I have about 15 years of software development experience with C, C++, driver development, firmware, and embedded systems. This course is intended for beginners and also intermediates. Students with background in computer science, computer engineering, EE. Also for professionals with some experience with systems programming. This course is not just for driver developers, but also for developers who are interested to know something about Linux kernel internals, Linux drivers, Linux cross-compilation technique, a Linux USB subsystem, network driver, GPIO, SPI, synchronization techniques in OS operating systems. Also, this course is beneficial for a hobbyist as Linux and embedded systems are getting more prevalent. Linux on rise with embedded systems from cell phone, home alert systems, and also upcoming self-driving vehicles, and so on. Okay, let's go over objectives of this course. The first is overview. I will talk about overview of this course in the beginning. I'll provide information on what hardware or embedded devices will we be using in this course. We will also talk about embedded systems in general with the topic on SPI, Serial Peripheral Interface. Second one is Hello World Device Driver. We will basically develop a simple Hello World module. I will explain Linux device driver model. We will also talk about Linux system calls and character driver and develop a character kernel module. PCI device programming. I will go over PCI Express, PCI topology, enumeration, BDF like bus device function, root complex, root ports, PCI bridge, endpoints in x86. I will also talk about PCI config space and bar, base address registers. We will basically write a PCI driver to prove on Intel network controller and explore its configuration space. Introduction of OMAP 3530 embedded device. We are using OMAP 3530 embedded device for part of this course. I will explain U-boot, NFS, network file system, TFTP boot, cross-compilation of Linux kernel, and kernel deployment or porting on OMAP. Basic GPIO programming on OMAP 3530. We'll modify existing driver to add GPIO, general purpose I/O programming to toggle OMAP's backlight on or off. Okay. Next one is synchronization. I'll talk about POSIX threads. Synchronization object. We will use either mutex or semaphore. I will explain producer-consumer threading model. We will basically write user space application and also kernel module to utilize the concept. We will also implement ring buffer or circular buffer in kernel space to store our data. Seventh is basic USB programming for microchip PIC18F embedded device. We will develop USB kernel module and interface with PIC18F embedded device. We'll create Qt-based application to toggle LEDs and also a value from potentiometer on PIC18F board. We will also talk about USB subsystem in Linux and various USB data flow type. Okay. Number 8. Lastly, introduction of network device driver on x86. Basically, we'll write a pseudo network device driver with implementation of ping functionality. We'll create our own network host and test the driver using Wireshark. It's a tool to analyze network protocol. I will also explain ICMP reply and ICMP echo. Finally, thanks for signing up for this exciting course. If you have any questions, concerns, or even suggestions, don't hesitate to reach me. Thanks again. Enjoy.